Hello everyone, myself Mrs. Rama Ranjankar, lecturer in Electronics and Telecommunication Department from Praveen Patil College of Diploma Engineering and Technology, Bhindar. Today I am going to explain Chapter 4 Wave Propagation Part 2. In this chapter we are going to part we are going to discuss the space wave propagation, line of sight propagation, optical and radio horizon, multipath propagation and duct propagation. Let's see the concept of space wave propagation. Space wave propagation is defined for the radio waves that occur within the 20 km of atmosphere, that is troposphere, comprising of direct waves and reflected waves. These waves are also known as tropospheric propagation, as they can travel directly from the Earth's surface to troposphere surface of the Earth. It is also known as line of sight propagation, as the signals are sent in straight line from the transmitter to receiver. In order to prevent the attenuation and loss of signal strength, the height of antennas and the distance between them can be given as dm is equal to 2 RH of t raised to 1 by 2 plus 2 RHR raised to 1 by 2, where dm means distance between the two antennas, r means radius of earth, ht means height of transmission antenna, and hr means height of receiver antenna. The propagation of these waves happens along the line of sight distance, which is defined as the distance between the transmitting antenna and receiving antenna. It is also called as range of communication. So this diagram shows the space wave propagation. Here the two antennas are given. One is a transmitting antenna and another one is receiving antenna. When the waves directly transmitted to the receiving antenna as shown in straight line, so that waves are called as a direct wave, and another waves are reflected from the surface of earth and move towards the receiving antenna, so that waves are called as a reflected waves. So the space wave propagation has three components: direct wave, so also called as these waves are along in path. Radio waves reach the receiving antenna directly. Ground reflected waves, the radio waves reach the receiving antenna after reflection from the ground. And the third component is tropospheric wave. The radio waves reach the receiving antenna after reflection from the troposphere. Now the another terms related to space wave propagation. So this slide includes the defines the meaning of direct wave, reflected wave. So space wave propagation includes radiated energy that travels in lower few miles of Earth atmosphere. So they include both direct and ground reflected wave. Direct waves travels in essentially a straight line between the transmitting and receiving antenna. Most common name is line of sight propagation. And the field intensity at the receiving antenna depends on the distance between the two antennas and whether the direct and ground reflected waves are in phase. There are some limitations of space wave propagations. As a form of electromagnetic radiation, like light waves, radio waves are affected by the phenomena of reflection, refraction, diffraction, absorption, polarization, and scattering. There are some limitations of space wave propagation. These waves are limited to curvature of the earth. And another limitation is these waves have line of sight propagation, means their propagation is along the line of sight distance. Application of space wave propagation. It is used in various communication systems like line of sight communication and satellite communication. It is also used in radar communication, in microwave linking, as well as space wave propagation limitations also. Let's see the term line of sight propagation. So as shown in diagram, there are two antennas. One is a transmitting antenna and another one is a receiving antenna. So as the signals are directly passes from transmitting antenna to receiving antenna, then that type of propagation is called as a line of sight propagation. Okay. So here the transmitting and receiving antenna must be within a line of sight. Okay, so when it's possible, when both the antennas are line of sight with each other, as that only line of sight propagation occurs. Refraction, so bending of microwaves by the atmosphere. Then refraction occurs when the velocity of electromagnetic waves is a function of a density of the medium. When the wave changes medium, speed changes, and when the wave bends at the boundary between the mediums. So let's see the multipath propagation. So this is a diagram for multipath propagation. So here one is a mobile receiver, and this receiver mobile or moving around around this surface or around this special area. So though it mobile or though it moving here and there, still it is in connection with the transmitter. So this is called as the multipath propagation. Another example for multipath propagation. So multipath is a propagation phenomena in wireless communication. According to it, the receiver antenna will receive 2 or more copies of the same signal from different routes. So different routes are very, very important. So such kind of propagation is called as multipath propagation. Let's see the term optical and radio horizons. So this is a diagram for optical and radio horizon. The radio horizon is the locus of point at which direct rays from an antenna are tangential to the surface of Earth. If the Earth were a perfect sphere without an atmosphere, the radio horizon would be a circle. The radio horizon at the transmitting and receiving antennas can be added together to increase the effective communication range. Radio wave propagation is affected by atmospheric condition called as ionospheric absorption and the presence of obstructions, for example mountains or trees. So let's see the duct propagation. So why the ducts occur? Why we get the ducts? Because the weather alerts the temperature, pressure and humidity. So regions of air are moved out, mixed up, elevated and depressed by the cyclones and anticyclones. Radiation from the land raises the air temperature near the ground. The ground cools quickly on clear nights, and the evaporation from areas of water can cause the local high humidity gradient. And this diagram shows the duct propagation. The useful range of troposphere is roughly 100 to 700 km, and it can be used from 144 MHz through 10 GHz. The illustration shows the troposcatter path between two sites. The scatter volume is marked by cross hatching, and the scatter angle, which is the angle between the radio horizon rays of two stations, is called as scatter angle. The radio horizon ray for an antenna is the ray that marks what is called the takeoff angle. for the antenna, which is the lowest elevation angle that will clear all the obstructions in the direct path to other station. These are the examples for troposcatter communication. Thank you.